Hello guys, it's Miss Treese. In this video, we're going to be talking about classifications of matter. So let's get started. Okay, so first off, just what is matter in general? And we're going to get more specific and break it down from there. Okay, you guys probably know that like pretty much everything is made up of matter. There's really only two classifications for something to be matter. It has to have mass. Let me fix that. Have mass and takes up space or has volume. That's it. Those are the only two classifications for something to be matter. So that is pretty much everything. So we need to be able to break it down further. Now, another characteristic of matter is that it cannot be created or destroyed. And you guys may recognize that because you've probably heard that several times, throughout life, and we will talk about it several times in chemistry. But guys, that is the law of conservation of mass. Sorry, it takes a while to write, so my brain works much faster than my pen does. So that is the law of conservation of mass, that matter cannot be created or destroyed. And then guys, we can break matter down further into pure substances and mixtures. I'm going to start over on the left side of our notes here, and we're going to go through pure substances, what they are, talk through them, and then we're going to go back into mixtures. All right? So pure substances. Obviously, when you hear the word pure, I think of just, all the same thing, like nothing else in it, things like that. I always think of like water, like pure water is just water. There's nothing else in it. It's nice and clean. We're going to talk through the characteristics of pure substances now. So pure substances have, oh my goodness, I'm having all those struggles with my screen moving. Pure substances have a fixed composition. Basically, what that means is that they are made up of one thing. So, for example, if we were talking about water, it's only made up of water, which is H2O. So 2 hydrogens, 1 oxygen. And that's all it is in the whole substance that we're talking about. It's only water. So they have a fixed composition. And pure substances are always going to be homogeneous, or they are going to look the same throughout. So we'll talk more about homogeneous in a minute, but you guys, if you think back to biology, the prefix homo means the same. So homogeneous means that it's going to have like the same look throughout. So for example, I'm just going to hold up what I've got, like my Post-it notes. They all look the same. They have the same like formula. They're all made up of paper or whatever, but you get the idea. So same throughout. Okay, and then our pure substances are always going to have a symbol or a formula. And really what we mean by that is that our pure substances are either elements or compounds. So the symbol represents the element from the periodic table. So if you guys know, on our periodic tables, each element has a symbol that represents it. And then the formulas would be for compounds. So compounds is where 2 or more elements combine together, and we write that in a formula. So like H2O, that's a formula. So that's what we mean there by have a symbol or formula, is it's just made up of that one thing. And so it's got that symbol because it's an element. So it's like all made up of the same element, or it's a formula and it's got multiple. All right, cool. So let's talk now and go down and go further into like pure substances, and let's break them down into elements and compounds. So I'm going to start with elements. Guys, I'm sure you've kind of know what elements are, but elements are made up of only one type of atom. So if I was talking about oxygen, for example, and I have the element oxygen, it's only made up of oxygen atoms. So only made up of atoms that have those 8 protons that are typical of oxygen. And then elements cannot be broken down at all. So cannot be broken down. Ooh, if I could write. Cannot be broken down physically or chemically. Now, we will actually learn next unit about how we can break elements down. And we can break them down through nuclear reactions, but they can't be broken down physically or chemically. They are what they are. All right. So then just some examples of elements. You can list your favorite elements here. So I like gold, which is the symbol on the periodic table is AU for that one. I don't know, whatever you like. Carbon, which is C. And then sulfur, why not? Sulfur, which is S. So those are our elements there. Okay. Now then, over here, we have our compounds. All right, and compounds are 2 or more elements chemically bonded together. All right, so there are 2 or more elements chemically bonded together. So what happens is in a chemical bond, it typically has to do with the electrons. The electrons are either transferred over from one element to another, which makes one positive, one negative, makes them attracted to each other, or the electrons are shared in between 2 molecules. And so when this happens, it creates a chemical bond. We're going to spend a whole unit talking about these chemical bonds, but just to kind of let you know, it's all about those electrons. And guys, in these compounds, elements are in a fixed ratio. So, elements in a fixed ratio. What that means is that I'm always going to have the same number, the same ratio between my elements. So, for example, I'm trying to think through compounds. Y'all know water, so H2O. All right, in water, it's always going to be 2 hydrogens and 1 oxygen in that formula. So they're always in that same ratio. Okay, so let's list some examples of compounds. So just some that you guys might know off the top of your head. So like carbon dioxide, which is CO2. That's the formula for that. Glucose, you guys probably learned glucose last year in biology. C6H12O6. And last but certainly not least, salt, table salt. Table salt is NaCl. So those are just some compounds you guys may know. Now, guys, our compounds are chemically combined. So they're combined through those bonds, but it's chemically combined. And so they can actually be separated. And they can be separated by chemical means. And when those compounds are separated, they typically break down into their elements. So typically this happens when they undergo some sort of chemical reaction and they break down into their elements. So for example, water will actually break down through electrolysis, which is basically where you run an electrical current through it, and it breaks down into its elements, hydrogen and oxygen. Okay. Now I want to talk about some special elements, guys. And these special elements are called diatomics. And these are elements that are always going to, when they're by themselves, they're always going to exist in a pair. So they're always going to come in 2s. I have a couple different ways to remember them, but I just want to talk through them. They are elements still, because even though they do come and they are bonded to another atom, it's the same because it's going to be 2 of the same element bonded together. So it is still an element. It is not a compound because it's just made of one type of atom still. So I use the word Brinkelhoff to help me remember my diatomic elements. So that is bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Brinkelhoff. That's the way I remember them. So they always are going to be when they're by themselves in a chemical reaction or just when we're talking about them. And typically this occurs in the gas phase for most of these, except for like iodine and bromine. Iodine is a solid and then bromine is a liquid. But these are always going to come in pairs. So Br2, I2, N2, Cl2, H2, O2, F2. They're going to be, when they're by themselves, they come in a pair. And then there is a couple other ways to remember this as well. So the first one is I have no bright or, goodness, I keep forgetting to capitalize what I mean to capitalize, or clever friends. So this one's kind of a mean way to remember it, but live your life. So iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, fluorine. I have no bright or clever friends. That's another way to remember it. And then the last one is 17. Okay. And so I'm going to actually have to, I'm going to show you guys this one using my big periodic table in my room. So I'm going to go over the 17 method of determining and remembering our diatomic elements. So our 1 comes from hydrogen. Since hydrogen is the first element on the periodic table, that's how we can remember that it's part of Brinkelhoff. It's the 1 in 17. And then the 7, if we start at nitrogen and go down to iodine, it makes a lovely 7 on our periodic table, and that's where the 7 comes in from 17. So 1 is hydrogen, and then 7 is the shape of the elements on the periodic table. Now guys, you can use any of the 3 methods that we talked about, Brinkelhoff, I have no bright or clever friends, or 17, any of them will work. Pick your favorite. I personally like Brinkelhoff. I think Mr. Oglesby likes I have no bright or clever friends. So just pick your favorite. Any of them will work, and any of them are kind of fun, I think. So now we've talked all about pure substances, elements, and compounds. So now let's get into the other side of our flow chart over here, and let's talk about mixtures. Okay, guys. Obviously, a mixture is 2 or more things mixed together. I know. Crazy. So mixtures is 2 more things, typically 2 or more pure substances mixed together. But kind of characteristics of mixtures is that they have variable compositions. So what that means is that they are made up of different things. So they are typically 2 or more substances, typically pure substances, that could be an element, compound, whatever, mixed together, and they are physically combined. So they are 2 more substances that are physically combined. All right, so since they are physically combined, that means they can be separated by physical means. And we will talk all about physical separation techniques in another video that you guys will watch in just a few minutes once you finish this one. So they are separated by physical means. All right, guys, now we have 2 types of mixtures, homogeneous and heterogeneous. So guys, if you think all the way back to biology last year, the prefix homo means same. And then the prefix hetero means different. So that kind of gives us a clue to what we are looking at in our homogeneous mixtures and our heterogeneous. So let's start by talking about homogeneous. So homogeneous mixtures are ones that look the same throughout. Or we might say that they have a uniform appearance. So this is like, I always think about salt water here when I'm thinking about homogeneous mixtures, because it's salt mixed in water. So it's two different pure substances, water and NaCl, mixed together. But you really can't tell, you can't see the salt and you can't see the water. There's no difference between them. It just looks uniform and the same throughout. So that's what it's talking about. Now, these homogeneous mixtures are also called solutions, and we will actually do a whole unit where we talk about solutions next semester. So get excited. Solutions. So they can also be called, struggling with my writing today. Solutions. It's interchangeable there. Okay, so let's think through some examples. So obviously I already said salt water as one. Another is like Kool-Aid, or really any type of like mixed drink, lemonade, Kool-Aid, powder mixed drink. I don't know what's cool now. And then the last one is alloys that I want to talk about specifically. So alloys. And alloys are actually a mixture of metals. So it's two or more metals mixed together. And you guys probably know a few alloys, but like brass is an example of an alloy. Bronze is an example of an alloy. Steel, things like that. Those are all alloys, and it's two or more metals mixed together. All right. Whew. Then coming back up to heterogeneous. All right, guys, so where homogeneous looks the same throughout, heterogeneous is not uniform. It looks different. So it's, two or more things that look different put together. And they just may even be in like a different phase. So what I mean is that you may have like one solid and one liquid, or one gas and one solid mixed together. And so they may be in a different phase of matter. They can be in the same phase, and they could just be like a different size or a different color, something like that as well. Okay, so some examples of heterogeneous mixtures are like trail mix is an example. So, you have your peanuts, you have your raisins, and they're all solids, but they all look different. And so that could be examples of a heterogeneous mixture. Kind of salad would be an example of that as well, because you have your lettuce, you have your tomatoes, your onions, your carrots. I don't know what you put in salad, but your salad could be an example of that. And then another one I think about is like sand and water. So you have your sand, you have your water, they're together, like the sand, the water don't mix. So you have your solid at the bottom and your liquid at the top. All right. Now, guys, heterogeneous mixtures, or heterogeneous, either way, technically it's the same. But heterogeneous mixtures can be broken down into colloids and suspensions. And basically the difference between colloids and suspensions is all about the size of the particles in the mixture. So in a colloid, they have medium-sized particles. And those medium-sized particles cannot be filtered out. So so colloids are a little different, and they're typically like they can't be filtered out. So I don't know what I was trying to say. They can't be filtered out. And this actually causes the Tyndall effect to happen here. So the Tyndall effect is basically when we shine light through a solution, and when we shine it through a colloid, it causes the light to scatter, which means that we are actually able to see the light in our solution because it hits those different particles and reflects off of them, and it causes them to scatter. And the Tyndall effect is actually why our sky is blue, because in the air there's lots of like dust particles and things like that that are suspended in our air, and so light hits them whenever they're coming, and blue light is just reflected much more frequently than like red light is, which is why our sky is blue, because of the reflection of that. So some examples of colloids are the air. Shaving cream is an example of a colloid, and so is Jello. Gelatin, any kind of gelatin is going to be a colloid substance, mixture. I don't know. I can't talk today, guys. All right, and then the next one we have is suspensions. Okay, and so suspensions have really large particles, and these large particles can be filtered out. And they will also typically settle over time. So some examples of this, I don't know how many of you are coffee drinkers, but if you are like, kind of a snobby coffee drinker, you might make French press coffee. But if you think about coffee and the grounds, like coffee and the coffee grounds are really big and they're pretty easily filtered out. If you pass it through a filter, they're pretty easily filtered out. So coffee and grounds. And then another one that you might think of is like Italian dressing, salad dressing. And guys, I'm talking about like zesty Italian dressing, where you have like the big chunks of things in the liquid dressing. So Italian dressing. And then another one is a lava lamp, is an example as well. All right. So there you go, guys. We filled out that whole big chart all about the different types of matter. So now let's practice a little bit. All right. So let's come here and we are going to classify each of these as an element, which is just made up of one type of atom, a compound, two or more types of atoms chemically bonded together, a mixture of elements and compounds. This will be where we have like two different elements or two different compounds, mixture of elements only, or a mixture of compounds only. So let's get started. So this first one, we have a compound because we have two different elements. We have our like black element there and our white element, and they are bonded together. And so it's like one black element to two white elements there. And so that one would be a compound. They all look the same. There's no different kinds of compounds there. It's all the same. So that's just a compound. Our next one, all right, we have this singular, like only one black atom, and then singular, only one white atom. And so this one would be a mixture of elements because we have two or more elements. They're not combined together, so that means they can't be compounds. So that would be a mixture of elements. Now this last one might be a little trickier. See how you guys do, but this is actually a mixture of elements and compounds. So obviously this one is our compound because it's two or more elements combined together. But this one is an element. And guys, this would be one of our diatomics that we talked about. And it still counts as an element because it's the same atom. So it still counts as an element because it's the same atom. Okay, so now I want you guys to do the rest of the practice on this page. Pause your video and then come back and we will quickly go over it.